Okay, so today we're going to actually not get through a tremendous amount of lecture material. There's a lot of other stuff that I want to go over today. I'm going to show you a demo of the course project. We have a more or less fully working version. I'm going to spend some time explaining how the overall project is organized, talk specifically about homework 7, which we got out very late last night. We're going to talk about that as well. I want to spend some time quickly reviewing the test. The grading guidelines will be on the website very shortly. I have them. I just have to spend some time reformatting them. And you can submit regrades, I'd say, until the end of next week. So, blah, 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 most of the stuff that we've seen already. We are going to shortly end Chapter 6, which is classes, or at least end the current discussion on Chapter 6, and then move into arrays. That's Chapter 8. I want to get to arrays prior to the end of the lecture on Wednesday, just because I want this lab is going to be on arrays, and you're going to have to do a couple array manipulation stuff. And then future homework is going to be on arrays as well. So we're going to be moving into Chapter 8. We're then eventually going to come back and do some more stuff on classes. That's Chapter 6, and there's a higher number chapter as well that talks more about classes. So let's see. We've generally caught up with the grading. Last night at some very early hour of the morning, I returned all of the assignments that were finished grading, homeworks 4, 5, labs 6, and 7. We currently have 3 assignments out. I'm hoping we can get them returned by the end of this week. We'll see how that goes. And let's see. Oh, yes, I'm getting dunked. Or hopefully not, but a week from this Wednesday at 10:20 a.m., I'm going to be sitting on a dunk tank, and you can all come and either watch me get dunked or try to dunk me yourself. I'm not quite sure what cause this supports, but I think it's like $25 for 5 tickets. I will tell you right now that if it's a cold day, then there's a limited number of times I'm going to be able to get dunked before I catch hypothermia and die, and I told them that. They haven't actually set a location yet. They just said show up at 10:20. I'm assuming it's kind of hard to hide a dunk tank in the engineering complex, so I assume it will be obvious. But yeah, so come watch me get dunked at 10:20. I think the TA is already planning on videotaping that and putting that up on YouTube as well. Okay, questions, comments, concerns? All right, let's spend a bit of time going over the test, and I just wanted to quickly review what the right answers were for a lot of the questions, and to a certain extent talk about what we were looking at, what we were looking for. So obviously what lab section you're in, everyone got that one right this time. Well, actually, no, we have had people who have entered, just accidentally checked off the wrong one, and yes, we really did take 3 points off. Actually, the whole reason we put that question there is it makes it much easier for us to grade the exam if it says your lab section. If we didn't count it as points on the test, then nobody fills it out. That's why we put it there. So classes and objects, what we're looking for there is something to show that a class is a template, a recipe, a cookie cutter, and an object is what you actually create with it. Just how a type is some sort of template for allocating memory, 4 bytes, make it look like an int, and then you start creating a whole bunch of int variables. Same thing with classes and objects. The halting problem. There are many creative answers for this. The halting problem is, can you design an algorithm that, given some program, optionally with some input, will tell you yes or no whether or not that program will halt or will loop forever? And the reason it was such an importance, so this is the next question, is this was the first algorithm ever to be shown that cannot be solved by a computer. Cannot be solved, period, much less be solved by a computer. And this was done in 1936 by Alan Turing, long before computers actually existed, well, about a decade before computers existed. He was able to show that even if we were to get a fancy schmancy computer, we still cannot write such a problem. Well, we need to use the equals method when comparing string objects. If you use the double equals operator, it just compares the references. And generally, when you're comparing string objects, what you want to do is compare the text of each of those particular objects. And that's what the dot equals method does, is actually compares the actual letters of one string to the letters of the other string and returns true or false if they're the same. Whereas the double equals operator will just compare the references. While and a do while. A while checks the Boolean condition at the beginning of the loop, and therefore before it starts executing. A do-while loop checks it at the end of the loop, and therefore it'll execute the loop once before it even bothers checking the condition. I don't remember what the answers were on this, but I mean, one could trace through it or type it in, and it gives you some answers. What we intended on this one is we meant to have the people answering this. Oh, where's the text tool? Here we go. Take this text here and convert that into an if-else statement. But what we ended up seeing is some people said if amount 1 is greater than 5, and then inside that, if amount 2 is less than 10, and then inside that, put that line just as specified. And we didn't say that you had to do it one way or the other, so we actually accepted both. This one we were fairly lenient on just because it was poorly stated. It was basically looking for something along those lines. This bug here, so that program is supposed to increment, go through all the even numbers, and the for loop itself increments a number by 2, and then this increments a number once more. So every time it goes through, it's going to do multiples of 3 instead of multiples of 2. So the bug there is that line shouldn't be there. So we accepted many variations of that as long as it generally showed, printed the number 0, 5, 10, the multiples of 5 all the way up to 50. This was fairly straightforward, converting to a while loop. For I equals 100, semicolon, I is greater than 0, semicolon, I minus minus, and then that was the body. For this one, a lot of people forgot. Oh, geez, I have a scratch on my. Oh, that's too bad. I have a nice crack on my screen. For this one, we were looking for basically something that would iterate through the vector, or start at the beginning of the vector and go all the way up to the end. And a lot of people forgot that there's the dot get method. So there certainly was a lot of partial credit if you used some other similarly named method. Oh, nope, that's going up. So most of these are, the answers for this was void, double, I'll get to that in a second, int, and string. This one here, we meant to imply that that was a constructor. In the circle class, that's what the beginning of the default constructor will look like. But we realized we didn't specify what class it's in, so therefore, if that's in a square class, Java's not going to think it's a constructor because the name of the method, circle, does not match the name of the class, square, and Java would give an error. So we accepted pretty much anything for, we accepted either none, constructor, NA, or error for that, because all those could potentially be right answers. That is definitely not void, because there is no word void there, so it doesn't actually have a return type of void. This just required sort of tracing through all this. I don't remember what the answers are off the top of my head. And this just required writing a distance fallen method. We ignored public, we ignored static. The return type had to be double. It was a bit unclear from this one. You may assume gravity is fixed at 9.8 meters per second squared. Some people interpreted that as there is a constant already defined, which, you know, being as we were a bit vague in it, we allowed that as well. But essentially, it takes in a parameter, that parameter being time, and then it returns 1/2 time squared times g. So it can actually be just one line method. Any questions on the test? How many people thought it was too hard of a test? How many thought it was hard but fair? Easy. Okay, so there's a good balance. My goal is hard but fair, and it seems like that's certainly the majority opinion on this. Okay. So the first homework is the course project. And I wanted to spend a bit of time. I'm actually going to play the course project for you right now in an effort to show you what it is that you will eventually accomplish. So there's about a dozen different classes that you will have to write for this project. Some we will provide in part. Some, like this game class, we're going to provide pretty much in full. Others you're going to have to write. And I'm going to talk about the split of that in a moment. So, right. compile. All right, so let me just make this a bit bigger. Properties. Is that generally readable in the back? Oh. Is that generally readable in the back? No? Oh, boy. How's that? If you cannot read this because it's too small, raise your hands. Okay. So this is our fancy schmancy game. It's the Oregon Trail game. And first that we'll see there is we have a map. This map, you'll notice, isn't particularly filled in, and there's actually a very good reason for it. And that's the map, that part right there. F is a finish. That's where you're trying to go, kind of Oregon-like, if you imagine that that's a map of the U.S. S is start. Independence, Missouri, Indifference, Missouri, one of them is where one started in the actual game. And the goal of this game is to move from the lower right all the way up to the upper left. And there's going to be a whole number of letters and characters for the squares. You'll notice that there are periods. Periods is grassland, very easy to move across. Vertical bars, kind of like a stick, so that represents a forest. And the little peaks, or the carrots, those are mountains. D means there's a depot, which means there's a place that you can buy and sell goods. So you'll notice that we have a whole slew of commands here that I'm going to spend some time talking about. So first, we are at a bland mountain. So the particular terrain that we are currently in is mountains. It can be mountain, grassland, or forest. And it turns out we can customize that, as I'm going to talk about in a minute. There is a depot there. That's what this little D means, so I can buy stuff and sell stuff there. At coordinates 9, 9, so we're trying to go to 0, 0. It's a 10 by 10 map, so we're starting at 9, 9. It tells us we have $1,000 to spend as we see fit, and we haven't actually gone anywhere yet. And these are all the commands. Now, you'll notice that some of them have X's there because they're not actually implemented. I am not sure if we are going to implement them for this project, just because implementing them adds a lot of complexity, and this is already probably more complex than it should be. Question?
And then there's that XT enable cheat mode.
Yes.
Is that also not?
Oh, yeah, that is enabled. Just the 4 that are highlighted are the ones that are not currently working. So whenever you enter a command, you just enter it by the first letter. So if I wanted to move, I would just enter M. And it tells me that I can't actually move without any oxen. Because this is Oregon Trail. This is like 1850. I'm trying to get from point A to point B. I have my wagon, and I need some oxen to actually pull it. So what I'm going to do then is enter the depot for D. So I'm at some depot, and there's a price factor here. In the actual game, the further you got, or the closer you got to Oregon, the things got more expensive. Same thing here. The further you get away from the starting point, the more expensive things become. Here, it's a price factor of 1, which is sort of like base price. And you're going to see as we get further and further away, things end up getting more and more expensive. Once you're inside a market, so there's essentially 2 menus. There's the one menu, there's a normal menu, and then there's a menu inside a market or inside a depot. Once you're inside a depot, you can check to see what's available. There is 1,000 units of food, 100 units of ammunition, 100 oxen for sale. You can buy all the ammunition you want, but being as you can't hunt, I'm kind of holding off on that. The hunting's been disabled, or not been enabled. So let's buy something. I'm going to buy some oxen. I'm going to buy 10 oxen, and I've spent $100, bought 10 oxen, and I'm ready to go. Now, we're going to work on balancing this. I think oxen are actually going to be slightly more expensive, but we'll get to that later. Okay, I'm not going to buy ammunition, and as you're going to see, I'm not going to buy any food either. I can hit I and see what's in my inventory. You'll notice I have $900, no food, no ammunition, but I have 10 oxen ready to go. I could sell stuff, but I'm not going to do that. So hit E, and that exits the market. and then I'm back at the particular location. So essentially, my map is a 10 by 10 grid, or there's a total of 100 location spots, and ultimately, I suppose you could travel to all of them. So, okay, the various commands. W for world map prints the map of the world. M was already taken, so hence why it was W. You'll notice that I know where I'm trying to go, but I can only see 2 units in any direction. So I can't see what's 3 units ahead or 3 units behind. And then what I can do is I can hit M, and I can choose a direction I want to move, and I have now moved 1 direction north. And you'll notice now that this is where I am. But you'll also notice that I don't have enough food, and my party is starving. So what I can do is hit C for check, and it shows the particular members of my particular party. I've designated myself the leader, and I have 4 randomly chosen TAs that are accompanying me on my ill-fated journey, oh, I didn't say that, to Oregon. So, okay, let's look at the map, move north. You notice I'm still starving. Move north. So, a couple other things to notice here. So this is where I currently am. There's a depot north of me. I might actually make it and not have everyone die. Oh, look, Kevin Richards found some wild fruit. And other than him, he's doing pretty well. Scott Geyser died. But the rest of us are still going. So there's various health things that can happen. Oh, Scott Geyser is dead, was struck by lightning. You could get dysentery, you could break an arm, you could be bitten by a snake, et cetera, et cetera. I'll have to let Scott know his fate. So I want to move north again. Michael Chapman just passed away from typhoid. So, right, and now if I look at my party, we're not doing so well. Once I hit 0 out of 10 health, everybody dies. And Kevin's doing pretty well, but the rest of us aren't. So now I think I'll go into the depot and buy some food. So you'll notice here that we have a higher price factor. I have moved further away from my starting point, so things are a bit more expensive. And the food here is therefore a bit more expensive. So how much food would I like to buy? Let's buy 400 units of food. I have 116 left. I think I'll hold on to that for a while. Oh, so I can hit my inventory. I still have my 10 oxen. I now have 100. Ooh, I need to round that. But I have $116 and like 1/1,000,000th of a cent, and 400 units of food. So there's a whole number of other commands that we haven't really talked about. I can check my inventory here as well, and it just tells me what I have. I can also rest, and what rest does is rest allows me to sort of recoup my health. And in particular, I think it's like 1 health unit per day. So I'm going to rest for 8 days, and everyone's going to be ready to go. And then if I check my party status, you know, other than the fact that the late Michael and the late Scott aren't around, everybody otherwise is full health. So let's see, what other commands that we have? Oh, yeah, so then check, we've talked about quit leaves. And then, of course, there's the cheat command. What the cheat command does is it will show the entire map. So this map that we see here, basically, every square we've been to, we can see, and every square within 2 squares of where we've been to, we can see. So as we start moving around the country, more of the map will become available. And eventually what we're going to have to do is sort of dodge the mountains, especially, and then dodge the forest. We can move quickly through grassland, but not so much up and down a mountain with 10 oxen pulling a wagon. So then I can start moving. I have dysentery. You'll notice right there I have dysentery. Kevin was struck by lightning. Am I going to make it anywhere? Ooh, I found some fruit. Okay, come on. Oh, Scott's corpse was struck by lightning. Yeah. Kevin died again. I think we'll have to fix that bug. Ooh, I have a broken leg. I think I'll rest for a bit. So there's only me and Trevor are the two people that are left. Michael died again. Michael died again. So I finally got to my destination, and poof, I've won the game. Well, Trevor and I won the game. The rest didn't. And that's essentially what the project that you are going to be implementing is what you saw here. There's the one command I didn't show was the cheat. The cheat command gives you $1 million and shows the entire map. Those are the two things that it does. It might actually prevent you from being struck by lightning or anything like that. But that's pretty much all of the commands. Now, what we wanted to do is we wanted to make this customizable. So you can pick your own names for who you want your party members to be and who you want your leader to be. When I play this, I think as I was developing it, I had my 4 pets as my 4 traveling companions. And what we're showing right now, so most of the stuff that you've seen here is for the Oregon Trail game, right? We have grassland, mountain, and forest as the terrain type. If you want, you could completely make this into a space trading game or a space traveling games where your terrain types are like empty space, nebula, and, I don't know, star cluster or something like that. And again, you can move across it. I mean, the same basic idea. You need to get from point A to point B with limited resources and in a certain amount of time. You can choose the name of the vehicle you're in. So right now it says wagon. It could be like the Starship Enterprise or the Millennium Falcon or the Death Star if you want to travel across space in a Death Star. So, I mean, to a certain extent, there's a fair amount of customizability. And one of the labs, I don't think it'll be this Thursday's lab, but either this Thursday's lab or next Thursday's lab, you're actually going to develop a class that provides that customizability. You're going to provide, you're going to specify the leader's name, the party members' names, the various health things. So, I say have dysentery, has a broken leg. Yours can be was eaten by space aliens, or, I don't know, what futuristic things happen. So one thing to think about is what particular version of the game you want to play. If you want to run around the UVA dorms, if your goal is to get from point A to point B on UVA grounds, then that's fine too. If you want to make this a streaking game, where that's the rotunda and that's the statue that I'm told people run around, you can certainly do that as well. I mean, pretty much anything you want. And when we get to that point, we're going to provide some possibilities. Okay, questions? All right. So, I want to run this once more. So I know in the back you probably can't see it, but you'll notice that, no. So this is the map, and if I hit the X button, and then it tells me that I have, all right. So I hit the X button, which allows me to cheat, and it tells me that I now have $1 million, and it actually shows my entire map. So that's what the cheat button does. It's really the idea. Most of the reason cheat codes are built into games is for developers, because this way, as you're developing it, you can just go through and check. You hit the cheat button, and you can check if your terrain looks like it was generated properly. Were there too many mountains, too few mountains, et cetera, et cetera. So that's, I think, the last one that we did. Oh, yeah. And the other way this game can end, of course, Okay, so let me go into the depot, buy some oxen. How about 100 oxen? Nope. Okay, I just depot move. So I'm just moving without any food, and you'll notice that we all died. So essentially what I did there is I just moved north without any food. Everyone starved to death, and Paul Turner, Joe Orville, Isabel Rivest, they all passed away. I'm sorry, Paul. I think apparently me and whoever the other TA is got struck by lightning or something prior.
Why with 100 oxen 50 days?
I was hoping no one would ask that. This was a question. This is something that I was doing very late last night. The more oxen you have, the shorter time it takes. That formula I kind of screwed up, and we'll get that fixed very shortly. I was just hoping no one would notice. There's one or two other bugs in here, but my goal yesterday actually was getting the very delayed homework out in time. There's a couple bugs. Like when you rest, it tells you how long it took you to travel while resting. Yeah, details. Yes? This game keeps going as long as one party member is alive. What happens in the real Oregon Trail if the leader dies? You can just keep going? Okay. So this, if everybody passes away, then like this, the game ends because everyone died. Otherwise, you can just keep going till at least one person gets to the end. I think at the end we'll probably have something that will determine a score based on how healthy people were and stuff like that.
Is there like any penalty if your group leader dies?
There's a question of, is there any penalty if your group leader dies as opposed to any other member? One of the things I'm going to put in prior to when that part of the assignment is given to you is calculating a score. It might be that the leader getting there is worth more than the rest of the party. I haven't figured that out yet.
Shouldn't it not matter how many oxen you have? Because oxen can only move so fast. They're not exactly like really speedy animals. So no matter how many you have, they can't move fast enough.
That's a very good point. So the thing is shouldn't it not really matter much how many oxen you have? And to a certain extent, that's the sort of realism part that I might ignore. Like if you were doing a space trader game, instead of calling them oxen, you could call them engines, right? And if you put 100 engines on your ship, you're going to just speed across space really quickly. So yes, maybe we could call them horses, and horses can certainly move. Or maybe that there's a maximum speed that they can move. Because if you have a lot of weight in your wagon and 10 oxen, you're going to move faster than if you only have 5 oxen. Still not faster than an oxen can move. And part of that is that formula that I still have to work out. The map is randomly generated. It's a 10 by 10 map. There are a slew of parameters to this that I'll briefly show you in a second. But basically, about half of the spaces are blank. About half of the spaces are grassland or whatever you choose. Again, I call it grassland, mountains, and forest. You can call it anything you want. About half of the spaces are grassland, about a quarter are mountain, and a quarter are forest. There's another question there somewhere. Yes?
You should make the oxen die.
I'm sorry?
Make the oxen die.
So that was something that happens in the real game is your oxen can die, like if you're fording a river and your oxen dies. There were a lot of things that I would like to put into this game, but my fear actually is that it's already too complex. So if I start putting in a lot of things like hunting, actually hunting is going to be easy, I'll tell you why in a second. Trading or changing a pace or changing the food, that would add a lot more complexity. So having the oxen die is something that you can certainly add, but it's probably not something that we're going to require. In terms of hunting, so hunting is you take a day off, you go around, you try to pick up some animals so that you don't starve to death. In the actual game, it's sort of, you're sitting there and you can move around in a little spot, and an animal comes by and you keep hitting your key to get your gun over in the right direction, and then you try to shoot the animal, and that's how you hunt. I think we're going to do sort of a random hunt. Like you say you want to hunt, and it randomly determines how much food you find. That might make it easier. Yes?
In the real game, you have
So in the real game, you can play any of three professions: a banker, a carpenter, or a farmer. And the banker has the most money, the farmer has the least, and the carpenter has about in the middle. And when you get to the end, you get the most amount of points if you're a farmer, middle points if you're a carpenter, and very few points if you're a banker, because there aren't any banks in Oregon. Well, back in 1850, there weren't many banks in Oregon. There are a lot there now. So I don't think we're going to add professions. Again, like a lot of this, because really what I want you to see in this, partly is how to design a big program. Partly is how to split something like this into many different classes. And then you are certainly welcome to add that. It's probably not something we're going to do. Okay, other questions, comments, concerns? So, there are a number of classes that are going to be written for this project, and I want to spend a bit of time talking about them. The classes in general represent the various parts of the game. For example, we have a person class, and person class represents, not surprisingly, one of the people in your party. Has a name, it has a health, and it has a whether or not they're alive or dead. Those are the particular properties of a person. And we create a person, so we're going to write a person class. That's actually part of this homework. We're going to create 5 person objects, and those are going to be the 5 people, or however many people are traveling across the country with you. Next up, we have a party. So a party represents the 5 people in your wagon. And the party is going to have it's going to designate someone as the leader, and 4 or however many people are going to be the followers or the non-leaders. So every party is going to have 5 of its own person objects. We have a vehicle. That's whatever you are using to move from start to finish, whether it's a spaceship, a wagon, a Corvette, anything that you want. We have a location. The map that we saw is a 10 by 10 grid. So there's a total of 100 spots that one can move to. And in each of those spots is a location object. The location object has a terrain type, mountain, grassland, or forest. Has an appearance, cloudy, overcast, rainy, dull, boring, what have you, et cetera, et cetera. So there's going to be a total of, in that one, there were a total of 100 locations in a 10 by 10 grid. The map class is what actually keeps track of that grid. It holds a 10 by 10 grid, and each one of those 100 spots is the given location object. Map printer just goes through and prints out the map to the screen as you saw, so it's going to print it out in some semi-graphical format. Parser, that's what's used to actually get all the user input. It will read the user input, what direction you want to move, what's your next command, that sort of stuff. Inventory, that's what holds things. So you notice that there were 3 things or 4 things that people could have: money, food, ammo, and oxen. And inventory is what actually holds that. Every depot, and I'm going to get to depot in a second, every depot has its own inventory because that's what the depot has, and a vehicle also has its inventory. So if you buy something at a store, then that stuff moves from the depot's inventory to your vehicle's inventory. I'm going to skip game for a second. So depot is just a market. That's where you buy and sell stuff. Control, that's just a couple of methods that deal with sort of progressing the game. At the end of every turn, for example, we have to check on who has dysentery that time around. So that's something that the control class does. Is it at the end of the turn, there's a method called, and it checks to see how far you've moved, adds up how much you've moved, so it keeps track of it. Keeps track of who just got dysentery, who just got typhoid, that sort of stuff. Question?
You just said depots have an inventory. Does that mean you can only sell so much stuff to a depot before it runs out of money?
Depots have inventory, but we're considering them to have infinite money. However, there's a maximum number of stuff you can buy. So a depot may not have a tremendous amount of, it may only have 3 oxen, at which point you buy those 3 oxen, then you have to go to another depot to buy more oxen. As far as we're concerned, there's Depots have an infinite amount of money because it's much easier to code that way. Descriptions is going to be the class that allows you to do the customization. That's where you choose all of your health problems, where you choose the name of your traveling party, the name of your terrain, and all that sort of stuff. And that's actually going to be done in one of the labs, and you basically get to customize your game that way. And once you do that and submit it, you can then change it if you decide you want to move to, I don't know, moving across UVA grounds as opposed to a space game, you can always change that. And lastly, the game class is what actually runs everything. It creates the map, it creates the vehicle, and sets the vehicle in motion. So that's the quick, high-level overview of the classes. I do not expect you at this point to have fully absorbed all that. This is an introduction to what you're going to see over the next month. We are going to be dealing with 2 classes in this homework, which I'm going to talk about in a second or two. And then in successive homeworks and labs, we will be filling out all of these. So eventually, by the time that this is finished, meaning when you submit homework 10, you will have a fully playable game that looks more or less just like the one that I just showed you. So homework 7, oh right, I have to talk about my wrath here. Homework 7 has 2 things that you need to implement. One is the location class. That represents, not surprisingly, one of the 100 spots, or however many spots there are on a board. Has three properties. No, a couple properties. Again, when we're designing a class, we need to think about what properties should it have. Well, it has an appearance, rainy, overcast, dark, dim. It might have a depot. I think about 1/20th of the locations have depots or something like that. It has a position, which is an X and Y coordinates as to where it is on the map. A terrain type, which is going to be one of, grassland or forest or mountain. And is visited. That's whether or not that spot has actually been visited by the player. So for each of these, you have a couple constructors to do, accessors and mutators, and then there's 3 other methods that one has to implement. Turns out, other than constructors and accessors, mutators, there's only 5 methods to implement, and they're all relatively short. Next up is a person class. A person only has 3 properties: a name, a health, and whether or not they're alive or dead. Again, constructors, 1 constructor, accessors and mutators, and there's just 2 methods therein. So those are the 2 classes, and it turns out there's one other thing that has to be done that I'll get to in a second. Actually, I'll get to that right now. So we've talked about testing your code, and this is something that we want to continue here, but we're going to continue in a very different manner. So if you look at the game.java, let me... So if you look at the game.java, there's a whole number of public static files. These are various constants and things that basically allow you to tweak the game. For example, how much oxen cost is eventually going to appear as one of these constants. It turns out that there's like 30 or 40 of these. How much money you start with, how much oxen costs, how much food costs, how much ammo costs, where you start, where you finish, how big the board is. I mean, it just goes on and on. Rather than throw 30 constants at you all at once, there's only like a dozen or so here. But what some of these are, so the location keeps track of the terrain as an int. And that int is either going to be terrain mountain, terrain forest, or terrain grassland, which means 1, 2, or 3. And then each one of those has a cost for how much it costs to actually move across it. It's much harder to move across a mountain than it is grassland, for example, et cetera, et cetera. What percentage of the map is forest, what percentage is mountains, blah, 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 blah. That's all talked about in the homework. And then what we want to do here is have you actually write code that tests your classes. And we actually provide that in terms of the person class. The idea is that you create a person object, whatever you want to call it, and then you go and check to make sure it was created properly. If I create a person object and the one parameter to the constructor, which is the name, is page, then I should be able to get, I should be able then, when I print out that person, it should print out the one that I just created. The idea is you call a method, maybe setHealth, and then you call the accessors of that object to check that it works properly. So for example, setHealth to 5, and then I'm going to call the getHealth method to make sure it returns 5. And by doing this, you can actually go through and write code that will automatically test your person class. As another example, I call changeHealth minus 200. Well, that's going to give them a health of negative 190, which is going to be fairly dead. So then when it prints it out, it should print out that the person has passed away. And this will allow you to be fairly sure that that particular method works. And that's the idea is you call some methods and then you call the accessors to make sure that those methods work properly. We provide the test code for person. I think we're going to add a bit more. I'll probably email the class when we do. You will need to provide it for the location. Yes?
To print out the name, how come sometimes you have to use that get name, sometimes to
One of the things we haven't talked about in too much detail is here, let's see. So here what I'm doing is I'm just printing out the person's name. All it will print out is Sally. Here what I'm doing is I am just printing out the entire person. It's going to say Sally with health, or Sally with health 0, or Sally who is dead, or something like that. And you'll notice here what I'm doing is test person is a reference to a person object. And when I just try to print out the reference, Java is going to look and see if there is a toString method. Well, that's a location toString method. Let's look at. So if you just try printing out a reference, like print out, system.out.println test person, Java will follow that reference and check to see if there is a toString method. And that toString method is what will actually print out. So that toString method is one of the ones you have to implement. That's going to go and say, I'm going to print out, this person has this name and has this health. So you can actually do both. You can print out the direct value returns from an accessor, or you can go and just print out the entire person that way. We haven't talked about toString yet. It's coming up very, very soon. Other questions, comments, concerns? So we did get this out much later than we had expected. And I talk about this a bit here. In particular, there's a couple things we did to try to make this homework a bit easier. One of them is there aren't a huge number of methods. Other than the accessors, mutators, and the constructors, there's only 5 methods that need to be implemented. 3 in location, 2 in person. Also, we provide all of the test code for the person class, and you just need to provide the test code only for the location class. I think that this is reasonable, even though, again, I apologize, we got it out late. Successive homework shouldn't be late because now everything's written. We're just chopping it up into parts for you to work on. If you still think this is unfair, and as I said it, if you feel you need to vent your wrath at somebody, please come and see either myself or Professor Coe in person, because also, as I say, it's much more interesting when wrath is vented in person. But if for some reason you feel that this is completely unfair, come speak to me. I tell you that if you come speak to me Thursday night or Friday morning, I'm not going to pay any attention. If you have a legitimate concern, and I'm happy to address legitimate concerns, then waiting until the last minute and realizing that, oh, I started this at 11 p.m. on Thursday night, that's not a legitimate concern that you waited till the last minute. But if you do have a legitimate concern that we got it out late, let me know. Okay, questions, comments, concerns on this? How many people feel they're sort of okay with what this homework requires? Okay, I'm seeing a good number of hands, not quite all of them. Look over the homework. Actually, wait, I have a couple I have 4 minutes. Look over the homework. It goes through and explains a lot of the stuff well. I kind of had to browse over it quickly. And if there are questions, we can chat about it on Thursday. So the last thing I wanted to mention was oh, I know exactly where it is. So, of course, yesterday was April Fool's Day. And Google is well known to come out with some April Fool's Day jokes. And I think some of the others were a bit funnier, but I wanted to spend a bit of time talking about this. So one of them is TISP, or Toilet Internet Service Provider. And this was this entire thing, and Google does like this whole press release, and a lot of, news organizations picked up on it, but this time they realized it was an April Fool's Day joke. In the past, they haven't. And it basically is talking about this entire way to get internet access through your toilet. So here's the kit that it comes with. You'll notice it comes with rubber gloves. And this is the overall system, where the idea is that you put on your rubber gloves, and then you drop this cable down your sewer line, plug it into your router, and this then is your internet access. And they go through and I'm not sure the idea is the funniest thing I've ever seen, but if you actually spend some time reading this, it's so deadpan and it's actually pretty entertaining. So they go through this entire thing. They have this fact and all these questions that you can ask. So then they also came out with don't log into my Gmail account. There we go. Gmail also had an account where you can go and start printing out paper copies of your email. Now, I keep every email I've sent or received, I have archived for the last 15 years. It's pushing 200,000 emails. And I actually have it all in my Gmail account because it's much easier to search. So I'm actually wondering how much paper that would take up if you print it. But the idea is that just like you can select a whole number of things and report them as spam, delete them, archive them, you can print a whole number of things, and Google claims that they will go and print it out for you, ship it to you for free. Yeah, I didn't think it was actually all that funny either. But I think the really humorous parts, and you may just think I'm completely loony or I've lost any sense of humor that I didn't have to begin with. If you are interested, I encourage you to read them in more detail, just because it's sort of the deadpan way that they address it that is fairly humorous. I think previous years, as I said, were more humorous than this year's. They talked about moving to a lunar base one year, or pigeons pecking computers was how they did the PageRank algorithm. Anyway, but these are some of the April Fool's Day jokes that briefly appeared yesterday. On that note, I'll see you all on Wednesday.